till now in the straight lines, 3 classes, part 1, part 2 and part 3, we discussed different forms of the straight lines and the problems based on them. So in today we discuss about the slope conditions we know as m1 is equal to m2 when the lines are parallel, and m1 m2 is equal to -1 when the lines are perpendicular. So today we discuss in the general form what is the condition for parallel lines and what is the condition for perpendicular lines, and moreover symmetric form also we discussed today and the problems based on that also. So let us see. Here the general form a1x plus b1y plus c1 equal to 0, then the slope is the formula we know as minus x coefficient by y coefficient and is equal to minus a1 by b1. And a2x plus b2y plus c2 equal to 0 implies the slope m2 is minus a2 by b2. Now condition for the lines when they are parallel. So that is m1 is equal to m2, we discussed at that time in the previous class. So then minus a1 by b1 is equal to minus a2 by b2. That is minus minus cancel and a1 b2 is equal to a2 b1. So this is the condition when the lines are parallel. See, a1 b2 is equal to a2 b1. That is the line when the lines are parallel. Now let us see the condition when the lines are perpendicular. That is the slope. The lines are perpendicular. See, that is a condition we know in the previous class. It is m1 m2 is equal to minus 1. That is minus a1 by b1 minus a2 by b2 is equal to minus 1. That is minus into minus plus a1 a2 by b1 b2 is equal to minus 1. That is a1 a2 is equal to minus b1 b2. Take that b1 b2, this side becomes a1 a2 plus b1 b2 equal to 0. So that is the condition when the lines are perpendicular. That is a1 a2 plus b1 b2 equal to 0. This is the condition for perpendicular lines. So this is a very important one we should remember. Now we go to the next topic, symmetric form. What is the point slope form we know? What is the point slope form? Y minus y1 is equal to m into x minus x1. See, symmetric form, a very crucial form which we apply very frequently. See, this also derives from the point slope form. When the point is px1 y1 and the slope is m, we derive from that only symmetric form. Let us see. So we know the equation of the line y minus y1 is equal to m into x minus x1. So m is what? Tan theta, where theta is the angle of the line with the positive direction of x-axis. So then I can write this m as tan theta. Y minus y1 is equal to tan theta into x minus x1. What is tan theta? Sin theta by cos theta we can say. So y minus y1 is equal to sin theta by cos theta into x minus x1. That is sin theta numerator come this side becomes denominator. So y minus y1 by sin theta is equal to x minus x1 by cos theta. This is the symmetric form. So let us see both are equal to a constant, say some r. So this can be constant, can be plus or minus. Okay, so you take, when these two you take, what will happen? That is y minus y1 by sin theta is equal to r. That is y minus y1 is equal to r sin theta. That is, what is y? y1 plus or minus r sin theta. Can be positive, can be negative. So y1 plus r minus r sin theta. Similarly, I take this constant, this relation, x minus x1 by cos theta. X minus x1 by cos theta is equal to modulus r. That is, x minus x1 is r cos theta. So x is equal to x1 plus or minus r cos theta. So we got any point x1 y1, I can say the xy can be x1 plus or minus r cos theta, y1 plus or minus r sin theta. That is, suppose this is the line. This is any point x1 y1. Suppose this is a particular distance r. So this will be x1 plus r cos theta is the x coordinate, y1 plus r sin theta for the y coordinate. So minus will be here, x1 minus r cos theta, y1 minus r sin theta. So this is a random point x comma y. I can say x1 plus r minus r cos theta, y1 plus r minus r sin theta. So that is, you can say like this also. So this is r cos theta. This is the angle of the line anyway. So this is a theta, r cos theta I am adding to the x1. So up to here it is, this is x1. x1 ki this r cos theta is this one. Because this projection here, r cos theta becomes here x1 plus r cos theta. That is the x coordinate here. And similarly, this is the y1. So y1 again, this r's vertical projection is r1 sin theta. So that we are adding y1, up to here it is y1 plus r sin theta. We are getting this point. Suppose this is P, we are getting some A and B. So the symmetric form can be used to find the random points when there is some distance r and some theta of the line, angle of the line you know with the positive direction of x-axis, then we can say the random point at a particular distance from the P. Okay, let us do some problems based on this symmetric form. Problems on the symmetric form. Problem 1. A straight line passing through the point A minus 2 comma 1 makes an angle of 30 degrees with the positive x-axis. That line is making 30 degrees with the positive x-axis. Find the points on the line, distance of 4 units. Find the points on the line. find the points on the line distance of 4 units from A. So we draw the diagram. Suppose this is a line. So making 30 degrees with a positive x-axis. So there is a point A minus 2 comma 1. He is asking a line passing through A minus 2 comma 1 and makes an angle of 30 degrees with a positive x. This line is making. Now he is asking find the points on the line at the distance of 4 units from A. So distance of on the same line we should find the points. 4 units means suppose there is a 4 units and behind 4 units. So here it is A, here it is B. So this is x1, y1 we take, and theta is given 30 degrees. So the point A will be A and B is x comma y, randomly I can say x1 plus r minus r cos theta, y1 plus r minus r sin theta. That is, first A is what? x1 plus r cos theta, y1 plus r sin theta. That is, what is A now? x1 is minus 2 plus r is 4 units, cos theta is cos 30, comma y1 is 1 plus 4 sin 30. That is A minus 2 plus 4 cos 30 is root 3 by 2, comma 1 plus 4 into sin 30, 1 by 2. That is A is minus 2 2 times. So plus 2 root 3. 1 2 2s are. So 1 plus 2. That is A is minus 2 plus 2 root 3 comma 3. Similarly for minus, for the point B we do. So B is x1 minus r cos theta, y1 minus r sin theta. That is, here say minus 2 minus will come, 1 minus will come, minus 2 plus, like that we will be getting minus 2 root 3. And here it is 1 minus 4 sin 30, y1 minus 4 sin 30. That is, I write here minus 2 plus minus 4 cos 30 comma 1 minus 4 sin 30. That is 1 minus 2. That is B minus 2 root 3 comma minus 1. So this is the point which is a distance of 4 units on the same line which is making an angle 30 degrees. These are the 2 points. By using the symmetric form we got this. Remember this formula. See, a straight line L through A2 comma 1 such that its point of intersection with straight line x plus y is equal to 9 at a distance of 3 root 2 units from A. Find the angle that L makes with the positive x-axis. See here, a straight line L through A2 comma 1. Suppose this is a line. Suppose A2 comma 1. A straight line L through A2 comma 1 such that its point of intersection with another line. Suppose there is another line. That is, the line is x plus y is equal to 9. At a distance of 3 root 2 units, this distance was given 3 root 2. So that is r is equal to 3 root 2 he has given you. At a distance of 3 root 2 and this is intersecting this x plus y is equal to 9. So find the angle that L, this is the L, makes with a positive axis. That is this line which is making theta. That we should find. We know this is you take as x1 comma y1. We know this is r. x1 plus r cos theta. You take this as some px comma y. So we know let px comma y be the point of intersection. That is, and the distance AP, distance is given 3 root 2, that is r. So x comma y is x1 plus r cos theta, y1 plus r sin theta is the point x comma y. What is this x comma y? Lies on this line. X plus y is equal to 9. So that is, what is this theta? Theta we have to find, or we know. x1 y1 we know. So 2 plus 3 root 2 cos theta. 1 y1 means 1 plus 3 root 2 sin theta. This point lies on x plus y is equal to 9. So you see, so substitute this point should satisfy there. That is x plus y, right? 2 plus 3 root 2 cos theta. Y plus I should write 1 plus 3 root 2 sin theta is equal to 9. This now we find theta value. See, 2 plus 1, 3. 3 plus 3 root 2, if I take common in these two, what will happen? Common, cos theta plus sin theta is equal to 9. 3 go that side, 9 minus 3. So 3 root 2 cos theta plus sin theta is equal to 9 minus 3, that is 6. Now 3 root 2 I divide on both sides. So by 3 root 2, so I write 6 by 3 root 2. 3 2s are, so 2 by root 2. Now what is left here? 3 root 2 cos theta plus sin theta by 3 root. That is, I am dividing 3 root 2 on both sides. Here also I am dividing, here also I am dividing. Here 3 2s are cut, 2 by root 2. So here 3 root 2 has gone. So what is left here? Cos theta plus sin theta. And here it is 2 by root 2. Now, this cos theta plus sin theta I convert dividing by root 2 on both sides. Divide by root 2 on both sides. That is 1 by root 2 cos theta (1 by root 2 cos theta), 1 by root 2 sin theta. So 2 by root 2, 1 by root 2. I am dividing 1 by root 2 on both sides. So this I can say cos pi by 4 cos theta. This 1 by root 2 I can say sin pi by 4 sin theta. 2 by root 2 into root 2, 2. 2 2s are 2 1s are 2. Will cancel. So now this is cos theta cos pi by 4 plus sin theta sin pi by 4 is cos A cos B minus sin cos A cos B plus sin A sin B. Cos A minus B. Cos theta minus pi by 4 1. So but what is cos value? It is 1. Cos 0 it is 1. So cos theta minus pi by 4 is equal to cos 0. So removing cos on both sides. That is theta minus pi by 4 is equal to 0 implies what is theta? 0 plus pi by 4. So what is theta now? Theta is equal to pi by 4. So like this, the angle can be found and the points can be found in the previous problem. Let us continue the third model. So take this. See, the third problem on the symmetric form. A straight line through q root 3 comma 2 makes an angle pi by 6 with the positive x-axis. And if the straight line intersects the line root 3x minus 4y plus 8 is equal to 0 at P, then what is the distance? Now you are asking the distance R. So we know this is the point root 3 comma 2 and this is the line which is making an angle theta is equal to pi by 6 with the positive direction of the x-axis. So this is x comma y and this line which is passing through Q is cutting the line root 3x minus 4y plus 8 equal to 0 at P, Px comma y. Here also we do the same thing, that is x is equal to x1 plus r cos theta, y is equal to y1 plus r sin theta. Okay, that point you find and that point lies on this line. So once you substitute here, that r distance PQ will be finding. Let the distance PQ is equal to R. We take now. So P x comma y is nothing but x1 plus r cos theta, y1 plus r sin theta. That is, here r we don't know, theta we know. That is, theta is given now pi by 6. x1 y1 also we know, root 3 comma 2. Q root 3 comma 2 is x1 y1. So substitute. Here root 3 plus r cos pi by 6, 2 plus r sin pi by 6, that is root 3 plus r cos 30, root 3 by 2, comma 2 plus r sin 30, 1 by 2. So that is root 3 plus r root 3 by 2, 2 plus r by 2. This is the point P. Now this point P lies on the line. So it should satisfy. So P lies on the line root 3x minus 4y plus 8 equal to 0. That is root 3x we got, root 3 plus r root 3 by 2. Minus 4y y is 2 plus r by 2 plus 8 equal to 0. So bracket open and expand. Root 3 into root 3, 3 plus r root 3 into root 3, 3r. R root 3 into root 3 is 3r by 2 minus 4 2s are 8. Minus into plus minus 4 into r by 2 means 2r. 2 2s are plus 8 equal to 0. So minus 8 plus 8 will cancel. So 3r by 2, 3 I keep here, 2r send that side, plus 2r, 3r by 2 send that side, minus 3r by 2. That is 3 is equal to LCM 2 by 1, 4r minus 3r. So 4r minus 3r is r by 2 is equal to 3. So what is the r now? 3 2s are 6 units. So therefore the distance PQ is 6 units. So on the symmetric form, we are using this symmetric form, we got the distance r in this form. Come, take down. See here, the next problem, a straight line through Q2, 3 makes an angle of 3 pi by 4 with the negative direction of the x-axis. If the straight line intersects the line x plus y minus 7 equal to 0 at P, find the distance PQ. See here, there is a line which is making an angle 3 pi by 4 with the negative direction of the x-axis, right? So here there is this line cuts the another line x plus y minus 7 equal to 0 at P, and Q is a point on this line 2, 3. So now the distance PQ is the question to find. See here. So we have to find means using the symmetric form, x is equal to x1 plus r cos theta, y is equal to y1 plus r sin theta. So r we don't know, theta we don't know, negative direction of x-axis we know. So we should find the positive direction of the x-axis. So this is 3 pi by 4 means, what is this angle? Pi by 4, because this is total is pi. So this angle will be pi by 4, because 3 pi by 4 plus theta is equal to pi. So theta is equal to pi minus 3 pi by 4, that is theta is equal to pi by 4, 4 pi minus 3 pi, right? So now this positive direction of the x-axis we got now. Indirectly the question angle was given to you. Now this theta you know, r you don't know, q x1 y1 you know. So find px comma y. So px comma y using the symmetric form is equal to x1 plus r cos theta and y1 plus r sin theta. That is x1 is 2 plus r cos theta is cos pi by 4, y1 is 3, r sin theta, r sin pi by 4, that is 2 plus r cos 45 is cos 45, 1 by root 2, 3 plus r sin 45, 1 by root 2. Now this is the point P. This Px comma y lies on the line x plus y minus 7 equal to 0. So P x comma y lies on the line what line? X plus y minus 7 equal to 0. That is x means 2 plus r by root 2 plus y means 3 plus r by root 2 minus 7 equal to 0. So r by root 2 plus r by root 2, 2r by root 2. Double now. 2 plus 3 is 5 plus 2r by root 2. Double. Minus 7. So 5 minus 7. Root 2 by root 2 is root 2r is equal to minus 7 go that side plus 7, 5 go that side minus 5. So that is 2 is equal to root 2r. So what is r? 2 by root 2. That is r is equal to, this is root 2 into root 2. So root 2. So root 2 units. So distance PQ is, therefore the distance PQ is equal to r is equal to root 2 units. Okay? This is the different methods, different form problems application wise. So the same symmetric form. Okay? Let us finish this one. Now we go to another problem with different model, which is a very important for the state board of exam important model we discuss now. See, it's a very important model. Transform the equation x by a plus y by b is equal to 1 into the normal form, and if the perpendicular distance of the line from the origin is p, deduce this condition. See, suppose given line x by a plus y by b is equal to 1, LCM a b. So LCM a b I multiply on both sides. So a b into x by a will cut, bx, a b into y by b will cut, ay is equal to AB into 1 AB. Now this is, I told you to convert this into the normal form. So coefficient of x b and coefficient of y a, squaring and adding under root, divide on both sides. That is, divide by root of b square plus a square on both sides. So the general form, to convert into the normal form, we did this under root of x coefficient square, y coefficient square under root. Okay, this same thing I explained in the part 2 why we divide like this. See, under root, divide bx by under root b square plus a square plus ay by under root b square plus a square is equal to ab by under root b square plus a square. This is x b by root of b square plus a square plus y a by under root of b square plus a square is equal to ab by under root of b square plus a square. This is in the normal form. What normal form? X cos alpha plus y sin alpha is equal to p, where alpha is the angle of the normal and p is the length of the normal or distance of the line from the origin. We discussed in the normal form. So suppose the line is like this. This is a line. The line is x cos alpha plus y sin alpha is equal to p, where this is the length of the normal, perpendicular. So this angle of the normal, this is a normal, p of length and this alpha. So the distance from the origin is p. So here this is in the form of x cos alpha plus y sin alpha is equal to P. So P is the distance is given. If the perpendicular distance of the line from the origin is P, so that is the length of the normal formula. P is the distance from the origin only. So I can say, what is P here? This is the P. That is AB by under root B square plus A square. So implies AB by under root B square plus A square is equal to P. Now reciprocating both sides. This becomes root of B square plus A square by AB is equal to 1 by P. Now squaring on both sides. Squaring on both sides. So this becomes whole square, whole square. That is, root will go B square plus A square by AB whole square is equal to 1 by P square. That is, B square by A square B square plus A square by A square B square. Because AB whole square is A square B square. That A square B square is the denominator for both. So for B square by this will come, plus for A square by also A square B square. So what will cancel here? Here. So 1 by A square plus 1 by B square is equal to 1 by P square. So this is a condition when the P is the perpendicular distance from the origin for this line. Okay? So for today, what we did, so the symmetric form, we did different parameters to be found in different applications, and condition when the lines are parallel, m1 is equal to m2, perpendicular m1 m2 is equal to -1, when the lines are in the general form, when a1 x plus b1y plus c1 equal to 0 and a2x plus b2y plus c2 equal to 0, then that is the lines, the slopes are parallel. Means when the lines are parallel, then a1 b2 is equal to a2 b1 we got. Then perpendicular lines means a1 a2 plus b1 b2 equal to 0. So these are the important points we consider today in today's class. Okay, we will discuss the further models regarding the application of the different formulae more, and the family of lines also we discuss in the next class.